Okay, so recently somebody asked me how one goes about computing the square root of I. And another way of asking that equation is, can we find a complex number whose square is equal to the complex number I? Okay, in particular, let's consider the equation z squared equals I, where z is an unknown complex number. The algebraic approach to this, it goes as follows. If we write z equals a plus ib, then a plus ib squared is equal to I. After some algebra, separating out real and complex parts, we see that the real part on the left-hand side is a squared minus b squared. That has to be equal to 0. The imaginary part on the left-hand side is 2ab. That has to be equal to 1. Now, when we write a squared minus b squared equals 0, or a squared equals b squared, only one possibility exists: a equals plus or minus b. So if a equals b, then 2ab equals 1 becomes 2a squared equals 1, and then we get two solutions. A equals plus or minus 1 over the square root of 2. However, if a equals minus b, then when we plug into the second equation, we get no solution. Therefore, we get two solutions like this. The real part is 1 over the square root of 2, and the imaginary part is 1 over the square root of 2, or both the real and imaginary parts are minus 1 over the square root of 2. Another way to think about this is using a geometric approach. So one way to think of the complex number I is to think of it as rotation by pi over 2, or 90 degrees. The formula that tells us that this is a really realistic way to think about this is Euler's formula. E to the I theta equals cosine theta plus I sine theta. And notice when we plug in pi over 2 for the angle, and remember pi over 2 in radians is 90 degrees, we get e to the I pi over 2, cosine pi over 2 plus I sine pi over 2. Cosine pi over 2 is 0, sine pi over 2 is 1, and therefore we get the equation e to the I pi over 2 is equal to I. So if we want the square root of that, well, it's already in the exponential form, so just have the exponential. Try e to the I pi over 4, and you notice that when you square that, you get e to the I pi over 2. And of course, the negative complex number of that is also going to be a solution. Let's forget about that for now. Let's just ask, what is e to the I pi over 4? Well, using Euler's formula again, that's cosine pi over 4 plus I sine pi over 4, which is 1 over the square root of 2 plus I 1 over the square root of 2, which is exactly what we got last time.